Exercise 1. Graph the solution set of the inequality y greater than x minus 2. Alright, first of all, this is a linear inequality. You know it's a linear inequality, the same kind of analysis you use to notice a linear equation. This inequality just has constant multiples of y, constant multiples of x, and constants. Okay, having said that, how will we even begin the graph of this inequality? Well, we can begin the graph by first graphing the boundary line. So first, graph the boundary line You obtain the boundary line equation by just replacing your inequality symbol with an equal sign. So the boundary line here will be the graph of y equals to x minus 2. Alright, well, this would be a straight line, and we can see the x and y intercepts. X-intercept, let y be 0, x is 2. Y-intercept, let x be 0, y equals negative 2. Okay, so a fairly simple coordinate system will fit this line conveniently. We'll sketch that. Okay, we'll label the axes. This will be x. This will be y. Scale the axes. 3, 3, negative 3, negative 3. Okay, now in a contrasting color, we'll get this boundary line going. Let's see, we mentioned that the y-intercept is negative 2. X-intercept at 2. Okay. Now, got to be a little careful. We're graphing the solution set to this inequality. This inequality has us graphing y greater than x minus 2. This boundary line is y equals to x minus 2. So the boundary line will not be solutions to this inequality. Since that's the case, I graph the boundary line using a dashed line. Okay. Like this. Okay. Now, this boundary line is important. It should be labeled with its equation. This is y equal to x minus 2. Now, since the inequality is in this form with a y isolated on the left-hand side, we can think of this as saying that the y's need to be above the line y equal to x minus 2 to make this true. And so we will shade everything above our boundary line. Okay, now we label the region with its inequality. This is y greater than x minus 2. Okay, now it's possible we have made a mistake in doing this. Okay, so let's check this. What could we do? Well, we've shaded a lot of points here. And by shading them, that means we're claiming they are solutions to the inequality, y greater than x minus 2. Why don't we take one of them, and if you're going to select one, probably something with some simple coordinates, like what could be simpler than 0, 0, right? Alright, in this case here, we have 0, 0 is a point in the shaded region. What's that mean? This means that 0, 0 is a solution to the inequality y greater than x minus 2. And what does it mean to be a solution to this inequality y greater than x minus 2? This means upon substitution, a true statement results. Okay, let's see what happens. Y is 0, x is 0. We'd have 0 greater than 0 minus 2. Simplifies to 0 greater than negative 2. Is this true? Yes. 0 is further to the right on the number line than negative 2. It's true, and that's just the kind of thing we were looking for here. That kind of completes our check, so we can be a little more confident that we didn't make some error in sketching the shading the correct side of the boundary line or these sort of things. Okay, so there we are. By the way, a little vocabulary here. This kind of region where you have a straight line boundary and everything to one side shaded, this kind of region is called a half plane. So let's be sure we know that. This type of region is called a half plane. Now we see that is the graph for this particular inequality, but it's more than this. It turns out that any linear inequality has a half plane graph. Basically, any linear inequality could be rewritten with y isolated on one side, and so then they always can be thought of as y greater than or less than some expression in x, linear expression in x. So it's always a matter of being above or below a line, and thus we always see half planes for the graphs of linear inequalities. Okay, keep that in mind as we do the rest of the exercises. Exercise 3. Graph the solution set of the inequality 3x minus 4y less than or equal to 12. Okay, after you examine this inequality for a moment, you come to the realization that this is a linear inequality. And what we know from this, as we saw in example 1, is that the graph will be a half plane. To graph a half plane, the most important thing we need is the boundary line. boundary line by taking the equality case of your inequality. So in this case, the boundary line has the equation 3x minus 4y equal to 12. Alright, if we're going to graph this line, we might consider the intercepts, and letting x be 0, y would be negative 3. Letting y be 0, x would be 4. Okay, so it looks like a small coordinate system will fit the important information. Let's sketch that. Okay, we want to label the axes. This will be the x's, this will be the y's. Let's scale this coordinate system. 1 centimeter is 1 unit. 1, 2, 3. 1, 2, 3. 1, 2, negative 3. 1, 2, negative 3. Alright, let's get ready to sketch this boundary line. Contrasting color. Okay, so let's go back again and get these numbers. If x is 0, y is negative 3. If y was 0, x would be 4. Alright, so let's connect these points with a straight line. And at this point we need to think about what to do here. Now this time, the inequality whose solutions we're graphing is or equals to 12. So the equation 3x minus 4y equals 12 is not only just a boundary line, it's part of the solution set. So we need to use a solid line when we graph this. A solid line, because we want this to be part of the solution set. Okay, solid line, there we are. You can label this with its equation. 3x minus 4y equals 12. Now, which side of the line shall we shade? We know it's a half plane, so we know it's one side of the line or the other. In this case, we don't have a y isolated, so it's not instantly obvious what above or below the line would mean. You could solve this for y. That's one way to do this. Another thing I like to do, it's faster, and that's I pick a test point, and I almost always pick 0, 0 when I can, and I see what is the case for 0, 0. If 0, 0 turns out to be a solution to this inequality, I know to shade all of 0, 0 side of the line. If 0, 0 turns out not to be a solution to this inequality, that means it must be the other side of the line that must be shaded. The other side of the line must have all the solutions. So, okay, here we go. Test 0, 0. Alright, putting it into the inequality. 3 times 0 minus 4 times 0 less than or equal to 12. This is 0 on this side, less than or equal to 12. What do we think about this? 0 less than or equal to 12 is true. Okay, so 0, 0 is a solution, meaning this entire side of the line, the half plane up here, is the solution set. Okay, so that's how we shade. Let's see. Alright, there we have it. And here we've got 3x minus 4y less than or equal to 12. By having the solid line here, that shows that this line is part of this solution set here, as we want. Okay, now let's test our solution here, or check our solution for errors. Okay, let's see, what could we do here? Well, keep in mind what we've done when we draw the graph of the solution set here. Everything that's shaded is a solution. So let's see, for instance, 3, 1. 3, 1 is in the shaded region. And what does that mean? Well, that means that 3, 1 is a solution to the inequality. What's it mean to be a solution to the inequality? That implies that upon substitution, a true statement must result. That's what it means to be a solution. Okay, well, let's try it out. 3, 1. 3 for x, 1 for y. Go into the original inequality. We've got 3 times 3 minus 4 times 1. Okay, now let's just work out what that is arithmetically. This is 9 minus 4 is 5. Now let's compare that to the left hand side. Less than or equal to 12. True. Okay, that gives us a little bit of confidence in our overall solution, seeing that it worked out for 3, 1 specifically. Okay. Exercise 5. Graph the solution set of the inequality negative x over 3 minus y over 5 less than 1. Okay, let's see here. Getting started. First thing, you might notice that this is indeed a linear inequality. Okay. So observe. The inequality is linear. And what's the implication there? We know that the graph will be a half plane. Alright, so as for starters, we need the graph of the boundary line. Now, as you look at this, you might decide there are several fractions here, a lot of negative signs. Maybe you want to do some algebraic manipulation here before you go further. Okay, how could we clean this up? We'd like to get rid of the thirds, get rid of the fifths, and maybe not so many negative signs. Okay, maybe multiply both sides by negative 15. Okay. This side by negative 15 and this side by negative 15. The result of that, okay, let's see here, when this multiplies by this negative x over 3, turns to a positive, factor of 3 cancels, it's 5x. Then there's this minus sign here, so that turns into a plus. A factor of 5 cancels, 3y left over. over here is negative 15. What about this inequality? Okay, important. When you multiply both sides of an inequality by a negative constant, you must reverse the inequality. So a less than sign must become now a greater than sign. So right there must reverse. Okay, and again that's due to multiplying both sides by a negative constant. Alright, having done that, our boundary line now can be considered to be the line whose equation is 5x plus 3y equals negative 15. Alright, for graphing this, let's see what coordinate system can we work with here. Maybe a quick check of intercepts might tell us what size will be alright. Let x be 0, y is negative 5. Let y be 0, x is negative 3. Okay, looks like we have quadrant 3 having most of the action in it, and otherwise a small coordinate system should fit everything. Okay, labeling the axes. X is here, y is here. Scaling the axes, 1 centimeter equals 1 unit. 3, negative 3, negative 3, 1. Okay, now in a contrasting color, let's get this boundary line graphed. X is 0, y is negative 5, y is 0, x is negative 3. Now we need to think here for a moment. This boundary line, it is not part of the solution set. This is a less than inequality. There's no or equals to about it. So we need to be sure to use a dashed line for this situation. Okay, the line here is, well, we could label either with its manipulated equation. Okay, I guess we can do that. 5x plus 3y equals negative 15. That's there. Now, the issue of shading, what to do here. We know it's a half plane, so what we can do is we can test a point such as 0, 0 and see if 0, 0 is a solution or not. If 0, 0 is a solution, that tells us the half plane is on 0, 0 side of the line. If 0, 0 fails to be a solution, that means it's the other side of the line that is the solution set region. Okay, so let's go here and test 0, 0. Okay, so we have 5 by 0 plus 3 by 0 greater than negative 15 upon substitution. This leaves us with 0, 0, 0 greater than negative 15. Well, 0 is greater than negative 15. It's true. So this means the solution set half plane is to this side, the 0, 0 side of the line. Okay. We could come here. We can even use the original inequality to label this region. This is negative x over 3 minus y over 5 less than 1. Okay, now, one remaining issue. Maybe we made a mistake here somewhere. Okay, let's start a check. Alright, let's see. Again, when you shade this region in like this, you're saying these are all solutions. Okay, so let's grab one of our solutions. Perhaps up here. 2, 1. Just some arbitrary point. 2, 1 is in the shaded region. Okay, this means that 2, 1 is a solution to the inequality. And what does that mean? That means that upon substitution, a true statement must result. Let's see what happens. 2 for x, 1 for y. Go to the original inequality before we did anything. This way, even our algebraic manipulation here is getting checked as well. So, we have negative x over 3. That makes this a negative 2 over 3. Subtract y is 1/5. And is it less than 1? Well, let's see here. Here's negative 2/3. We don't really actually need to do the arithmetic out. Have this negative number. We subtract something positive from it. That only makes it more negative. So surely this left-hand side is less than 1. It's true. And that's just what we wanted to see. Looks like it's a good solution. Okay. Exercise number 5, an alternate solution. Graph the solution set for negative x over 3 minus y over 5 is less than 1. Okay, firstly, we notice this is a linear inequality, 2 variables. So we know we're going to have a half plane for the graph. How about that boundary line? Well, the boundary line equation here could be a negative x over 3 minus y over 5 equals 1. Now, if you can recall, intercept form, that is x over a plus y over b equals 1. In this form, a is the x-intercept, y is the b-intercept. Okay, so here in our case, let's be very explicit about how we notice this is intercept form. We have then an x, we can write it as an x over a negative 3 to clearly expose this, and then plus a y over negative 5 equals 1. Alright, we have an x-intercept at -3, a y-intercept at -5. We begin our graph by making a lot of space for the third quadrant, it appears. Okay. Labeling the axes, x and y. Scaling them. 1, 2, 3, 4, -5. 1, 2, 3, 4, -5. Okay. Contrasting color comes out. By inspection, the x-intercept at -3. The y-intercept -5. Alright. Now, be a little careful. The inequality is a less than. We want to make sure it's a dashed line. Here's its equation. We can write the equation as a -x/3 minus y/5 equals 1. That's fine. Now, which side of the line do we shade? Let's test 0, 0 here. Okay, go to that original inequality. We have -0/3 minus 0/5 less than 1. This is all 0 here. 0 less than 1. Well, this would be true, telling us we should be shading 0, 0's side of the line. Can label our entire region here as being -x/3 minus y/5 less than 1. Okay, and the last thing we can do here is check over our work. Alright, let's see. For example, 1, 1 would be in the shaded region. So that means 1, 1 is a solution. And that means, upon substitution, into inequality, it must make a true statement. Must yield a true statement. Let's see what happens. 1 for x, 1 for y. We have -1/3 minusing a negative. That would be plus a 1/5 less than 1 is the question. Well, okay, let's see. We could do 15ths. This would be -5/15 and 3/15. That would give us a net effect of -2/15 less than 1. That's true. Okay, this looks good. Exercise 7. Graph the solution set of the inequality y less than 5. Okay, now this question comes as one of the questions from exercise set 2.1, whose title is two variable linear inequalities. So because of that, we know that we are to be graphing in the xy plane here. If this question didn't have that context, people would probably have to word this question a little more carefully. You might see a question like graph, and in here you might see in the xy plane the solution set of the inequality y less than 5. This way you know you can't, for instance, just take out a simple number line and take the numbers 5 and to the left and call that your graph. No, we're supposed to be in the xy plane here. Okay, so having clarified that, let's go on and say that this is indeed a linear inequality. So observe the inequality to be linear. Okay, what does that mean? This means we expect a half-plane graph. So we should graph the boundary line the y equals to 5. Alright, that's a horizontal line passing through the y-intercept of 0, 5. Okay, we'll get that up and running. Labeling axes, x and y. Scaling the axes, 3, 3, -3, -1. Okay, now contrast in color, and well, in this case we come up here to where y is equal to 5. And now we got to be a little careful. This boundary line, does it consist of solutions as well? No. We're about to graph a y equal to 5 line. That's not solutions to this, so we need to remember to use a dashed line. Okay, so this here is y equals to 5, the dashed line. Now as far as shading goes, okay, this time sort of by inspection, if the y is to be less than 5, that's everything below this line, and can label here y less than 5. And finally, although this is relatively a simple matter, to check our work, we could take the origin here, 0, 0. 0, 0 is in the shaded region, And this means that 0, 0 is a solution to the inequality. And this means, what does this mean by definition? Upon substitution into the inequality, a true statement must result. Okay, try it out here. Put 0 in for y. 0 less than 5. That's true. Okay, looks good. Exercise 9. Graph the solution set of the inequality x greater or equal to -2. Okay. One thing to mention first of all, and that's that because this question comes in an exercise set whose title is two variable linear inequalities, we know that the intent here is to graph the solution set in the xy plane. If that wasn't the case, a question like this out of context would have to be clarified a little bit here, and you might see a little additional phrase in the xy plane put in the question if it's intended to be a two-dimensional graph like we are doing here now. Otherwise, someone may come along and just take out a real number line and put a solid dot at -2 and an arrow to the right, and that would be the graph and would be really considered correct. Okay. Otherwise, we're in the xy plane, and we notice this is a linear inequality. Okay, so what does that tell us right away? We know the graph will be a half plane. Okay, to get that half plane graph, we need to get the boundary line. Equation is replace the inequality with an equal sign, x equal to -2. Okay, we recognize this as being a vertical line. We can get that going. Labeling axes. Scaling axes. 1 centimeter is 1 unit. Okay, get out a contrasting color to sketch up our boundary line. It's that vertical line, x equal to -2, and the consideration now is solid or dashed line. Alright, the inequality whose solutions we're graphing is an x greater or equal to -2. Okay, since the equalities are also part of the solution set, this needs to be a solid line. Okay. You can label it with its equation. X equals -2. And now the shading, which side of the line shall we shade? In this case, we can pretty much read it right off the inequality. The x's are to all be greater than or equal to -2. That would be to the right of -2. We just shade everything to the right of this line. Okay. Label our region x greater than or equal to -2. Okay, and just as a quick check on this matter, 0, 0 is in the shaded region. And that means that 0, 0 is a solution. And that means, by definition, upon substitution, into the original inequality, a true statement must result. Okay, let's try it out. 0 and 0. 0 goes in for x, greater than or equal to -2. Looks true. Just what we wanted to see. Okay, done.